Students, now we introduced the second chapter, relations and functions, and before going to the relation we have studied what is an ordered pair, how do we get an ordered pair, where do we represent an ordered pair, and what is the importance of ordered pair. Now based on the ordered pair we are coming to the next concept, what is called as a relation. Now let us recollect once again. Let there be two non-empty sets. Two non-empty sets. Two non-empty sets A and B. A and B. A contains the elements A, B, C. B contains the elements apple, ball, bat, cat, doll. Now, when you say A cross B, A cross B, number of elements in A cross B will be number of elements in A into number of elements in B. That is equal to 3 into 5, which is equal to 15. And let us write them. A cross B. A apple, A ball, A bat, A cat, A doll. B apple, B ball, B bat, B cat, B doll. C apple, C ball, C bat, C cat, and C doll. Now n of A cross B is equal to n of A into n of B. We have 15. 1, 2, 3, 4, 5. 5 into 3 is 3 rows are there. 5 into 3 is equal to 15. Now this is A cross B. Now we are going to study about what is a relation. Now based on this I am going to define a relation as R is a relation from the non-empty set A to non-empty set B, and it will be denoted in the form R is a relation from A to B. R is a relation from A to B. Now I will define as A apple, B ball, B bat, C cat. Now this is a relation, isn't it? Now when you identify the relation, you said A for apple, B for ball, B for bat, C for cat. Now when you consider the cross product A cross B and the relation, you can find that the relation is a subset of A cross B. Relation is a subset of A cross B. Sometimes we can see that relation can be equal to A cross B also. Sometimes it can be seen that relation can be a subset or it can be equal to A cross B. Here it is a relation A for apple, B for ball, B for bat, C for cat. Now when you say these words, that is the alphabets, the apple, ball, bat, cat, these are called as the images. These are called as the images. and this can be represented using a set builder form. The relation can be represented using a set builder form or roster form, or sometimes it can be represented by an arrow diagram. Now this is a new thing that you are going to study. Now set builder form, roster form, you have already studied in the chapter 1. Now the second case, we are going to study what is an arrow diagram. That is set A. Set A consists of the elements A, B, C. The non-empty set B consists of apple, ball, bat, cat and doll. Now here the relation is marked as A for apple, therefore there is a relation from A to B, B for ball, B for bat, C for cat. So the images are apple, ball, bat and cat. D, doll, is not an image of any other thing. Now in this set, when you consider, we are going to study some new words related to the relation. So this is an arrow diagram. Using arrow diagram, the relation is more easily or...
Why doll is not image?
Because I don't have any doll is not image because I don't have any element in A. I have only elements in A as A, B and C.
If D is there?
D is there, it can be connected to doll. It may or it may not be connected to doll. It is up to the relation. I have defined a relation such a way that A goes with apple, B goes with ball, B goes with bat, C goes with cat. So here I am defined a relation, that is alphabet A and the letter starts with the letter A. Alphabet B, word starting with the letter B, ball and bat. Alphabet C, the word starts with the letter C. So this is an arrow diagram, set builder form. Now when you consider this one, this is an arrow diagram. Now when you consider this, apple, ball, bat and cat, they are called as the images. Now the non-empty set A consists of set A, B, C. This is called as the domain. In a relation, the first elements are called as the domain. The first elements are called as the domain, and the elements apple, ball, bat, cat, they are called as the range. The set in a relation, the second set is called as the range, the first set is called as the domain. So you may think, what about if in the second set doll is also included? Yes, if the word doll is also included, it has another name. Doll is also included, it is called as the codomain. It is called as the codomain. So in a relation, there are three terms, that is the domain. That is, in a relation, the set of all first elements is called as the domain.
Orange or codomain?
Codomain.
The for containing set is called range.
It is called as the whole set, the set of second elements is called as the codomain. The definition is given in that form. So once again I will repeat, in a relation, the set of all first elements is called as the domain set. The set of all second elements is called as the range set, and the whole set of the second elements is called as the codomain. It is called as the codomain, and relation is easily represented by means of an arrow diagram. Now Suppose a set A has n elements, p elements. Number of A is equal to P, number of elements in B is equal to Q. Then number of elements in A cross B is equal to P into Q. That is n of A into n of B. And the number of subsets or the number of relations are from A to B. A to B, it will be equal to 2 raised to P into Q. It is of the form 2 raised to P into Q. Now we will study some problems related to this section. Now, suppose before that we will represent one more thing. What is a function? So we have completed with the relation. We will see what is a function. The name of the chapter is relation and function. So we have completed with the relation. What is a function? Now, when can a relation be called as a function? In the domain set, let us consider two non-empty sets A and B. The elements are 1, 2, 3, 4, 5, 6, 7. 1 is related to 4, 2, 5, 3, 7. This is a relation. Now, this relation is called as a function. Now, there is a relation from A to B. A to B. All elements of the domain set have images in B. So, we can say the domain set is equal to set 1, 2, 3. The range set is equal to set 4, 5, 7. And codomain set is equal to set 4, 5, 6 and 7. Codomain is equal to 4, 5, 6 and 7. Now, when can you say that this relation is said to be a function? When every element of the domain set has exactly one image. Every element in the domain, should have exactly one image. So this is a function because, and now it will be denoted in the form f is a function from A to B. F is a function from A to B, and it will be denoted as in the form f of 1 is equal to 4. F of 2 is equal to 5. F of 3 is equal to 7. So that means the image of 1 under the function, now this is a function, the image of 1 under the function is 4. The image of 2 under the function f is equal to 5. And the image of 3 under the function f is equal to 7. So these are the images 4, 5 and 7. These are also called as the range set. 4, 5, 7 is called as the range set. Set 4, 5, 6, 7 is called as a codomain set, and set 1, 2, 3 in the relation, this set is called as a domain set. Now, suppose in this case we can say that the pre-image of 4 is 1, pre-image of 5 is 2, pre-image of 7 is 3, but 6 does not have a pre-image, does not have pre-image. Pre-image. Now, this is a function. Now, let us consider another function. Another function. It's a function from the non-empty set X to the non-empty set Y. The elements are A, B, C, P and Q. Is this a function? The domain set is equal to set A, B, C. Domain set is equal to set A, B, C. The range set is equal to set P, Q, and the codomain set is also equal to set P, Q. Now my question is this a function? Condition is that every element of the domain should have exactly one and only one image. So f of A, the image, is equal to P. F of B is equal to Q. It has one image. F of C is equal to Q. It has one image. So that means it is a function. It is a function. That means every element in the domain should have exactly one and only one image. But what about the reverse? What about the reverse of these two? Now, suppose if I am defining the one more example, let us take X, Y, A, B, C, P. Is this a function? It is a function. Is it a function? Function from X to Y. Now we can say that F is not a function because C doesn't have an image. Doesn't have an image. Doesn't have an image. So it is not a function. Now another case is X, Y. A, L, M. A to L. Is this a function? It is also not a function. Not a function because there are two conditions which is against the rule of function. What are the against rules? A has got two images and B doesn't have an image. So this is not a function. The previous one is also not a function because C doesn't have a pre-image. C doesn't have an image. So the condition to be a function is that here it is a function. The second one is also a function. Now let us consider one more example. X, Y function 1, 2, 3, A, B, C. So I have given you many examples. First example, second example, third example, fourth example, and fifth example. In the fifth example, you can see that f of 1, the image of 1 is equal to A, image of 2 is equal to B, image of 3 is equal to C. Now, when you consider the third example, you can see that the pre-image of A is also equal to 1. The same thing. Pre-image of B is equal to 2. Pre-image of C is equal to 3. In the first example, pre-image of 4 is 1, pre-image of 5 is 2, pre-image of 7 is 3. But 6 doesn't have a pre-image. So, there is a difference between the first and the fifth example. The first and the fifth example, the difference is that in the first example, 6 does not have a pre-image, whereas in the fifth example, all the elements in the codomain have pre-images. So, if the codomain has pre-images, if all the elements in the codomain have pre-images, then they are called as inverse function. Inverse functions. Inverse functions, or they are called as inverse functions, or it is called as a 1-1 function. 1-1. 1-1. 1-1. 1-1. It is called as a 1-1 function, and in this case we can say that inverse exists. Inverse exists. But in this case, here we have said that it is not a function, so nothing is defined on that. Here also it is not a function. Now we are discussing about the inverse function. When you consider the second example, f of A is equal to P, f of B is equal to Q, f of C is equal to Q. Okay, so here it is a function. It is a function, but whether the inverse exists. When the inverse means P as a pre-image is equal to A. But when you consider Q, Q will have two images B and C. So, according to the condition of function, the domain set should have exactly one and only one image. So, when you consider the inverse function, Q will be the domain. Q will have two pre-images. Q will have two images. That means inverse does not exist. Inverse does not exist. Inverse does not exist. Coming to the first example, f of 1 is equal to 4. F of 2 is equal to 5. F of 3 is equal to 7. Okay, this is a function. But my question is whether the inverse exists. Inverse does not exist. Here, inverse does not exist. Inverse does not exist. Does not exist because 6 will not have an image. 6 will not have an image. So, for the inverse should exist, for a function, inverse can exist only if the function is 1-1. Inverse of a function exists only if the function is 1-1. So, once again, let me say relation. Relation means you will have the domain set, you will have the range set, and from the range set you have the codomain set. Now, when you say the function, when can a relation become a function? A relation can become a function if the elements in the domain set should have exactly one and only one image. One and only one image. So, the first one is a function, second one is a function, third one is not a function because C doesn't have an image. Fourth one is also not a function because A has got two images. Fifth one is a function because each element has one and only one image, and this is called as a function. Now, along with the function, I am going to define whether the inverse of the function exists. Inverse of the function exists means the second set becomes the first set and the first set becomes the second set. That means the inverse, it will be from y to x and it will be denoted by the notation f inverse. So f inverse is a function from y to x. F inverse is a function from y to x. Here f inverse of c. F inverse of c is equal to 3. F inverse of b is equal to 2. F inverse of a is equal to 1. So if it is a 1-1 function, then inverse exists. Here it is not a function, so no case of inverse. Here this is also not a function, so inverse does not exist. But in the second case, it is a function but inverse does not exist. Inverse is from y to x. Y inverse does not exist. Then y becomes f inverse of y. It is a function from f inverse. F inverse is a function from y to x. Y to x. In that case, when you define f inverse of q will have two images b, and f inverse of q will have another image c. So this is not a function because every element in the domain should have one and only one image. So this does not have an inverse. In the first case, the images are given. Now when you define the inverse, it is from b to a. B becomes the domain, a becomes the range. But here it is not a inverse does not exist because 6 doesn't have an image. The inverse will not be a function because 6 doesn't have an image. So these are the conditions for a function, for a relation to become a function, and a function can become an 1-1 function. And what is the condition for the inverse to exist? Inverse to exist. Now all relations are functions, but all functions are not, all functions are relations, but all relations are not functions. Once again, all relations are not functions, but all functions are relations. This is what you have to discuss, think about. So now we have studied about cross product, then relation, and in the relation we have defined, what have you defined? Domain, codomain, range, image, pre-image, and from that we define function. When can a relation become a function? So function is defined and the properties of function, and from function we have defined about the inverse of the function. When can a function have an inverse of the function? The function should be 1-1. Only then it will have an inverse of the function. Now let us consider some examples. Of some peculiar type of functions. First one is called as the identity function. Identity function. What do you mean by an identity function? An identity function means it is of the form f of x is equal to x. The form of the function is f of x is equal to x. It is called as an identity function. That is, if you say f of 1, it is equal to 1. F of 2, it is equal to 2. F of 3 is equal to 3. F of minus 1 is equal to minus 1. F of 0 is equal to 0, and so on. Now let us sketch the graph of the identity function. Let us sketch the graph of the identity function. x-axis, y-axis, origin 1, 2, 3, minus 1, minus 2, 1, 2, minus 1, 1, 1. 1, 1, 2, 2, 3, 3, minus 1, minus 1, 0, 0. Now, since the power of x is equal to 1, we join the points using a ruler. This is a graph of the function, identity function, f of x is equal to x. F of x is equal to x. Now, from the graph, what are the inferences you can understand? The domain of the function is a set of all real numbers, positive values and the negative values. X-axis gives a domain, so positive values and the negative values. What about the range? Range. It is also the set of all real numbers because it can take all positive values, it can take all negative values. Now, what about the function? You can say that it is a linear function. Linear function. It's a linear function. Linear function. And what about the slope? Slope. Slope means the inclination with the, it makes an angle of 45 degrees. It makes an angle of 45 degrees with the x-axis and the y-axis. And the slope is equal to, y is equal to x. So the slope is equal to 1. And the angle of inclination is equal to 45 degrees. It makes an inclination of 45 degrees and the slope. Slope is denoted by the letter, the alphabet m. So slope is equal to m. And the standard form of the linear function is, standard form of linear function is equal to, is y is equal to mx plus c. That is, here you have y is equal to x plus 0 or y is equal to x. So m corresponds to 1. That is, slope is equal to 1 and it is inclined at an angle of 45 degrees with the x-axis and the y-axis. This is called as the identity function graph. Since the power of x is equal to 1, we have to join the points using a straight line. I hope you understood what is an identity function graph and its properties. Now, one more graph we will study. It is the constant function graph. Constant function graph. Now, what is a constant function graph? The graph is of the form f of x is equal to c, a constant. F of x is equal to c, where c is a constant. That means f of 1 is equal to 2. F of 2 is equal to 2. F of minus 1 is equal to 2. F of 0 is equal to 2. F of 2 minus 2 is equal to 2. So this is called as a, whatever be the domain values, the image or the range will always be equal to a constant. Now let us sketch the graph of this function. X-axis 1, 2, 0, minus 1, minus 2, 1, 2, y-axis. F of 1. What is the value? F of 1 is equal to 2. F of 2 is equal to 2. f of minus 1 is equal to 2. F of minus 2 is equal to 2. F of 0 is equal to 2. That means graph y is equal to 2. Graph is a straight line parallel to the x-axis. Now, what can you say about it? Will this be a function? Arrow diagram, minus 1, minus 2, 0, 1, 2. The image is equal to 2. This is a function from A to B, but all the elements have one and only one image. One and only one image. So this is called as a this is called as a, it has got a special name, many one function. Many one function, many to one function, many one function. And what about the domain? Domain is equal to set of all real numbers. What about the range? It is equal to 2. In this case, it is equal to 2 because it all points out to only one value, that is equal to 2. Now, this can be in the form of x-axis, y-axis. It can be in this form also. Y is equal to minus 2. This is also a constant function. So this is also a constant function. So what is the constant function? Now let me read the constant function. The constant function is always a straight line parallel to the x-axis. Parallel to the x-axis, it will be above the x-axis in the case the value of its range is positive, or below the x-axis in the case the value of range is negative, and coincident with the x-axis in the case the range is equal to 0. When the range is equal to 0, it can coincide with the x-axis. It goes without saying that the slope of any constant function graph. What is the slope of the constant function graph? Because we have seen that it is of the form y is equal to mx plus c. But y is equal to minus 2. That means the x term is absent. Coefficient of x is the slope. Coefficient of x is the slope. But here there is no x term. That means slope is equal to, the slope of the constant function graph is always equal to 0. The slope of the constant function graph is always equal to 0. Properties of the constant function. Now let us just review this one. Basic properties of the constant function can be listed as follows. It's a linear real valued function. It is a linear function, straight line function. The graph of a constant value function is a horizontal line parallel to the x-axis that passes through the coordinate 0c. That passes through the coordinate 0c. Here it passes through the point 0, 2. Here it passes through the point 0, minus 2. Here it passes through the point 0, 0. It is an even function as its graph is symmetric with respect to the y-axis. It's an even function as its graph is symmetric with respect to the y-axis. Since it is symmetric with respect to the y-axis, the graph, it is an even function. It is an even function. The slope of the constant function is always equal to 0. Now, when you compare constant function and identity function, let me draw the small sketch of identity function. Now, x-axis, y-axis 0, 0. Okay. Both constant function and identity functions are real valued and linear in nature. They are both linear, first degree. While a constant function is a function that gives the same output. Constant function gives the same output for every value of the input. For every different values of the input, the constant function gives the same output. Whereas the identity function gives the same output as its input. That is 1, 1, 2, 2. That is 1, 1, 2, 2, etc. Here, for different values of x, you get the same value for y. Here, different values of x. 1, 1, the same value. 2, 2. The comparison between an identity function and the constant valued function. Next one. The graph of a constant function is a straight line. The graph of a constant function is a straight line parallel to the x-axis, which has a slope is equal to 0. And the graph of an identity function, it's a straight line passing through the origin, making an angle of 45 degrees with the x-axis, and the slope is equal to 1. Constant function takes the form f of x is equal to c. Whereas the identity function takes the form f of x is equal to x. So, this is a comparison between a constant function and an identity function. I hope you understood what is the domain, what is the range, what is the codomain, and many-one function, one-one function, inverse of a function, how to get the arrow diagram, how to represent the sets in the set builder form and the roster form, and the linear function. The equation of the linear form is y is equal to mx plus c, and the coefficient of x gives you the slope, and c is the constant, that is the y-intercept. It gives a y-intercept. Now we move on to some examples. For a short while we'll have a break. And then continue with the problems.